Hi everyone, we're going to evaluate the integral over the interval pi divided by 4 to pi divided by 2, which is 45 degrees to 90 degrees, of cotan 5 of phi and cosecant 3 of phi d phi. So I'm saying phi. This is little phi, I think. I'll just put phi. All right. So let's get. So basically, our integral is from pi divided by 4 to pi over 2, cotan 5 pi, cosecant cubed phi d phi. So, what we want to do is break this up. So let's first break this up as integral pi divided by 4 to pi divided by 2. And we're going to write it as cotan 4 to the 4th power of phi, cosecant squared of phi, and then add the additional ones, or multiply the additional. So that's cotan of phi, cosecant of phi, d phi. All right. Now, then what you can do is simplify this further and write this piece as cosecant squared of phi minus 1. I'm using my Pythagorean identities and square it, and then copy down the rest. So cosecant squared phi, cosecant phi, and cotan phi d phi. All right. Now, the reason I did that is I want to use my derivatives, and I want to let u equal cosecant of phi. So where we find cosecant here, that means derivative of u is negative cosecant of phi cotan of phi d phi, which is what we have here. So if you want, you can make this a positive and change that to negative, because we're going to use u substitution. So when you use u substitution, the only thing we have to deal with now is looking at these. Since we're letting u equal cosine of phi, this is going to change. So cosecant of pi divided by 4 is square root of 2. And cosecant of pi divided by 2 is going to, this is square root of 2, is going to equal 1. So when you write that, then we're going to write our u substitution. So this is u squared minus 1 squared. Then we have u squared. And then this whole piece here is just going to be negative du. Now, before I move to the next slide, since I have this as negative, I can get rid of that negative, or I can put it out here and change that to positive. At the same time, I can change this to positive by switching these two around, which is what I want to do. I want to keep the bigger number at the upper bound. So now what I'm going to write is my integral of 1 to square root of 2, and go ahead and distribute. You get u to the 6th minus 2 u to the 4th plus u squared du, and that's after I multiplied through. Now we can integrate, and we can get 1/7 u to the 7th minus 2/5 u to the 5th plus 1/3 u cubed, and we're evaluating it from 1 to square root of 2. So let's plug in our values. So this is going to be 1/7 times square root of 2 to the 7th minus 2/5 square root of 2 to the 5th plus 1/3 square root of 2 to the 3rd power minus, and when you subtract, you're just plugging in 1, so that's 1/7 minus 2/5 plus 1/3. All right, and simplifying further for your square roots, remember this could be written as square root of 2 to the 6th times square root of 2. So that's going to end up being 8 because you have 6 square roots. So we're going to end up getting 8/7 square root of 2 minus 8/5 square root of 2 plus 2/3 square root of 2 minus 1/7 minus 2/5 plus 1/3. Now your common denominator in all of this is going to be 105. And when you do that, you're going to get 120 minus 168 plus 70. And I'm pulling out the square root of 2. So I took these square root of 2's and just pulled them out and did the common denominator. Minus, and we have 105 again. And this is going to end up being 15 minus 42 plus 35. And that simplifies to 22 divided by 105 square root of 2 minus 8 divided by 105. And that's your final answer. Thank you. Have a nice day. Bye-bye.